So on line G, on page 3 of your table of contents, you are adding circle basics. Circle basics to line G. We're going to do these notes and we're going to glue this baby in today. We're going to use lots of colors. I use like 13 different colors, but not officially like 13 different colors. I kind of did like, dark and light green by pushing hard and not pushing hard. So that way I could find them in the picture. Because there's a lot of vocabulary on this paper. Did you add to your table of contents? Okay, I'm going to scroll. Circle Basics, page 60, on line G. And then we're going to go ahead and open our foldable up. Okay, you see lots of words on here. Scan them. How many of these words do you already know? Have you ever heard of any of these words? Which words have you heard of? Circle, diameter, radius, tangent, area, semicircle, circumference. And there are some words on here that you maybe don't know. But you know about half of them, so it's not like you're building a whole bunch of new vocabulary, but we'll review over them and we'll color them in the picture so we remember what they look like. Okay? I'm going to start off with, yellow because. All right. Okay, I'm going to go yellow on my circle. I'm going to underline circle. My circle in my picture looks like this all the way around. That is my circle. I'm going to color code everything. So I will color code. You can pick same colors as me, different colors. I don't really care. We'll do a little definition, just kind of a brief definition, not official definitions. Okay, I'm not going to write in yellow because I can never see that. A circle is all points equally distanced from the center. So these are points equal distance from center. All the points are equally distant from the center. And that's why you can draw it using a compass, because you stab it in the middle, you have the same distance, and you swing it around, it stays that same distance all the way around. So those are all the points equal distance from the center. How do we name a circle? Now remember, when we name like a segment, we put 2 letters with the bar on the top. If we name an angle, we make the angle symbol with usually 3 letters, right? So same thing with a circle. You make kind of like a circle with a dot in it. So when I'm naming a circle, he looks like this. Make a circle with a little dot in it. And you always name him by his center. So in this picture, who is his center? D. So you would see this, and you would just say circle D. So if you see that symbol, this means circle D. Circle D. I'll put that in little quotes. That's what that means. So you could write out circle D, just like you could write out segment AB. But you could also just write AB at the bar on the top, right? Okay, good on circle? I'm just going to go down the left and then down the right. Okie dokie. I'm going to switch to orange. Chord. I'll just color code new colors as I go. I might repeat colors and do dark and light by pushing hard and not pushing hard, just so we have difference. A chord. A chord is going to be a segment that has both endpoints on the circle. So I'm just going to write both endpoints, or I could do endpoints on circle. Both endpoints on the circle. What is the difference between on the circle and in the circle?
It's on like the line.
It's on the line that goes around it. Okay, so is everyone clear? On, maybe let's underline on. So not inside it, actually on it. Okay, so in this picture, an example, who has an example of a segment that would have two endpoints on a circle?
CH.
CH. Is that an example of a chord? C to H. That is an example. What's another one? Huh? B to where?
A.
B to A. That would be an example. A. A doesn't connect to H. If there were a line there, though, he could be, but we don't have
K
it.
to H.
K to H would work. You see different segments or different segments. It doesn't matter as long as both of the ends are on the circle. Good for a chord. Okay. I'm gonna go green. Kind of like green. Secant. So a secant is going to go through the circle twice or intersect it twice. Okay, so it's going to go through circle twice. It's got to go through the circle twice, not ending on the circle both times. And these things could be segments that go beyond. They could be lines that go beyond. They could be rays that go beyond, but they got to legit pass through it twice. Okay, now look at this picture. Do we see anything that goes through twice? Start where? Oh. B, A, L, K. You can't bend backwards. That's not a line or whatever. Oh my God. Something in my head. C, D, C, D, A. C, what? It's got, you gotta like find a line or array or something that passes, cuts through the circle twice. One thing of that.
C, D, H.
C, D, H. That does not go through it. It ends on it.
Oh, God, going
like
outside.
It's got to go on the outside. Through means all the way through.
L-A-D.
L. Okay. Here's one right here. This. You see that green line? Do you see how it passes through twice?
Yeah. L-A-B.
Yeah, you can do that one up there too. I'm not going to color extra ones though. I'll just color one from now on. So L. And this is a ray, correct? How do we name a ray? You have to do the arrow on the top, and you have to start with the endpoint. So you would call this ray LH. That definitely does pass through twice, all the way through. Good. Concentric circles we actually don't have in our picture. They're circles that have the same center. So I'll just go red. So circles with the same center. And so they're going to look like they have a center. They're going to look like bullseyes or something because they have the same center. So those are concentric circles. We do not have one in our picture up here. If I drew another circle like out here that had D as the center, that would be an example, right? He likes to see them. Okay, I'm gonna scroll a little bit. Area. Okay. What is area anyways? Area is the square units inside. Okay. I'm gonna go like I'm gonna do this like tan color. Area is square units inside. And if I was able to shade lightly, I would take my picture and shade inside here. It doesn't really work well with a marker on the board. In my notes, I shaded the whole inside like a tan color. So you might want to shade inside or not. It doesn't really matter. I'm not going to leave my mess up here because it doesn't really work with a marker. But it's the whole inside. Just shade lightly. Don't worry about coloring beautifully. And we do have a formula. What's the formula for the area inside a circle? It is pi r squared, pi r squared, pi r squared. Just so you know, on OST, there is, if you click up in your test, there is a formula sheet, and it is on the formula sheet, pi r squared. It says area of a circle, pi r squared. So it's not a formula you have to memorize, although you've probably been hearing it a while. And what is pi? Approximately 3.141597, blah, blah, blah. It's irrational, it goes on forever and ever. But we use the pi button on our calculator, so that way we don't round it until the very end. Remember, don't just type in 3.14, use the pi button, because that's the big long shebang. Just like when we did sine, cosine, tangent, go out 4 digits, just use the pi button because it's just going to go forever, and that's perfectly accurate. Okay, sector. Sector, I'm going to go like a light pink. Sector is basically a piece of pie. Okay, piece of pie. Piece of pie. In this picture, do you see the piece of pie? Where does it set? It has to go to the center, right? If you cut a pie, you're going right to the center. So do you see this pie? Here he is. This is my sector. And you can have little pieces of pie, and you can have really big pieces of pie too, right? A big piece of pie could, a sector doesn't have to be a little skinny piece of pie. It could be super big fat pie. As long as basically the vertex of it is at the center of the circle, it's a piece of pie. For the heck of it, let's just put a random angle measure in there. Like, let's say that this piece of pie is, I don't know, 40 degrees. Because if we know this angle measure, we can actually find the area of a piece of pie also. So if we don't want the whole circle, and we just want the area of some of it, which they definitely put on OST, we kind of use the whole area circle, and then we multiply it by the angle measure over 360. So let me show you down here. I'll scroll a little bit. Okay, so for a piece of pie, if we want to know the area of the piece of pie, we're going to start off with the regular formula, pi r squared. But we're going to times it by the angle measure over 360. So the measure of the angle over 360. So that's the measure of the angle over 360. Why 360?
The circle is
Because the circle's 360. So we're going to take the area of the whole thing and we're going to multiply it by the angle measure. So if in this case, we would plug in a 40 degrees right there and work this out, and then we can find the area of our piece of pop. Does that make sense? What I mean by the measure of an angle over 360. Always over 360 because that's the whole circle. Good on the vocab on the left side? Okay, let's go to the right side. You got all that so I can scroll back up? All right. Diameter. I'm going to go light blue. Let's do this light blue. This light blue. This light blue. It's a beautiful color. I really like that color. It's like Mikey's water bottle. Ish. Okay, diameter. What is a diameter? What has to be true about a diameter? Where does it start and end? So a diameter goes all the way across the circle through the center. So it's going to have endpoints on the circle and goes through the center. Okay? So ends on the circle. Ends on circle. And goes through the center, right? Oh my gosh, through center. Sorry about my writing. Ends on the circle and goes through the center. So the chords did not have to go through the center. They could have, but diameter has to go. So it's going to look like it basically cuts the circle in half. So in our picture, we only have one of them, right? It goes from H to C. So in our picture, we have HC, segment HC. So diameters are also chords, right? Just like a German Shepherd is also a dog. You got behind that the most important thing. Are you alive? Let's go. Catch up. Okay, radius. What's that? I'm going to go dark blue. Where's the radius at? Nope. That's circumference is around. So length around. And it starts in the middle. So it's a segment that goes from the center to the circle. So it's a segment, center to the circle. The segment to the circle. I mean, center to the circle. So in this picture, how many of them do you see? From the center to the circle. I see 3.
Oh, yeah.
Where are the 3? The first one that pops in your mind is probably this one, right? But don't forget there's one from there to there. There's also one from there to there, right? So there are actually 3 of them in this picture. So we can say segment DF or segment DC, because we're allowed to just go from there to there too, right? You'll be able to draw a million of them in here if you needed them, right? Wouldn't they all be the same length? Yes, they would, because you're taking this and just same length, swinging it all the way around to make the circle, just like you used a compass. Okay, now tangent. You have heard this word before. I'm going to go dark pink, hot pink. You have heard this word before in the vocabulary of a triangle. When we're talking about circle, now they are related, but when we're talking about in a circle, we're talking about something that touches only one point on the circle. So a tangent, something that is tangent, only touches one point on the circle. So he's usually on the outside of the circle and just barely touching on one of the sides of the circle. So touches only one point on the circle. Touches only one point on the circle. He's outside. Yeah, it's going to hit at E. Does everyone see where E is? Do you see that line that just touches it in one spot? So this right here, this line right here touches that circle only once. So it's always going to be like sitting on the outside edge-ish. So an example would be line EM. I put the little arrows over top because he does go on forever, right? Now, other things can be tangent to a circle. You can have two circles that are tangent to each other, like this. You could have this circle and this circle. You see how they're only touching in one point? So you can have two tangent circles also. So you can have other things that are tangent to a circle besides just lines. But they do only touch once. So that can be a circle. And this little spot right here has a special name. He is the point of tangency. He is the point of tangency. So if they talk about the point of tangency, you know that that's where that thing touches, just in that one little teeny spot. Point of tangency. Cool. Okay. Semicircles. I'm going to do like this dark red-ish color. Okay. What is a semicircle? It's half, right? So, semicircle is half. Actually, an arc that goes how many degrees? How many degrees?
180.
180. So it's an arc that goes 180 degrees. So in our picture, we need to go halfway around the circle. Where do you want me to go in my picture?
C8. Something like that.
C?
C8.
Let me scroll so I can see the whole thing. C to where? C to
Oh, C to E.
C to E to
Um,
all the way to H? That way? Okay, so let's go ahead and I'm going to draw him from C to H. Okay, and I'm glad you used extra letters because actually when we name them, we have to use 3 letters. Where you start and where you end and somebody in the middle. Okay, so if we're going to name that arc, where did he start? C. Now name somebody in the middle. Who did we pass by? E or F. I don't really care. Who do you want? E, okay. And where do we stop? H. Okay, so we name it like this, and we put a little archy on top of him. So this means arc CEH. So I'm starting at C, passing by E, and ending on H. Does that make sense? You couldn't just say at CH because you wouldn't know if I was talking about this side or that side then, right? So that's why you got to have somebody in the middle so somebody knows the path you got to take. And you just read that arc CEH, kind of like when we did angle CEH. We put the little angle symbol. Or up here, that's a segment, right? So they all have symbols, so that way you know how to name them. And the measure of him would be 180 degrees, right? They're also allowed to put the little baby M down here, like measure of this equals 180. So if you see the little baby M there, they're just saying the measure of that arc. Good? All right. Circumference. You know what? I did my circle in yellow. So I'm going to do my circumference in the same because it's going to be the exact same thing. Okay, so I'm going back to yellow because that was my circle color at the very beginning. Because look, when I talk about circumference, what is circumference? It's the distance all the way around, and I already have it traced in yellow, right? So I'm going back to my original color here. Circumference was in yellow because it's already drawn on there in yellow anyways. So circumference is the distance or length around, the distance or length around that means you have a circle and you put a piece of string all the way around the edge, you straighten it out, and you measure how long it is. That's what circumference is, right? It's a length or a distance. Okay? You don't care about inside anymore. Does anyone remember the formula? You can use radius or diameter. So you can use either just pi times diameter. That's the one I use because it's nice and easy, just pi times diameter. But what is true about a diameter in a picture? How many radiuses is a diameter? 2. So you may have also seen 2 times pi times r because it's the same thing because 2 r's make a d, right? So either of those formulas you will see. I don't know which one you learned. You see them both because 2 r's and a d mean the exact same thing. There's no powers though. Remember when we did area? It's square units, so we squared that number, right? Let's square the r. For circumference, there is no to the second powers. No powers. Okay, the next one we have stuff about a minor arc and a major arc. Minor arcs, major arcs are different. What's minor mean to you? Smaller. Major, bigger. Common sense, right? Minor arcs, I'm going to pick 2 colors, okay? I'm going to scroll down here. I'll scroll it back up in the picture in a minute. Okay, so I'm going to pick like a dark green for the minor. Okay, I'm going to do this dark for the minor. Okay, when you have a minor arcs are less than 180 degrees. So that means smaller than a half a circle. And I can see one right here in my picture. Do you see the little one? From H to F. See that one? Okay, so we name minor arcs with only 2 letters. So you're going to use 2 letters with a little archy on top. So if I wanted to name this guy, what do you think I would name him? HF. So HF with a little archy on top. So minor arcs are less than 180 degrees, and they are 2 letters. Why are you too sleepy? Both people whose names start with A. Nappy. Wakey, eggs and bacon. I love bacon and eggs. I love bacon. Okay, I'm gonna go like a dark, I'll go purple for my major. So what do you think a major is gonna be?
More.
Greater than 180, so he's going more than halfway around the circle. More than 180 degrees. We have to name him with 3 letters, kind of like we just did with the half circle. So we need to do 3 letters.
C-A-F.
Okay, 3 letters. I'll scroll up and check him in a second because I can't see the picture of this board here. Tell me when you're done writing that. Greater than 180, 3 letters. If you don't know your difference between greater and less than signs, you might want to put words by them. But minor, little, major, big deal, right? Okay, let's look at our picture. Okay, what did you say was more than half? From where to where to where?
C-A-F.
C-A-F. Look at C-A-F. That means C through A, stopping on F. Is that more than half? So that will work, right? So we call him C-A-F. And I'm going to go down and write that. So I'm going to see where we started with C-A-F. So with 3 letters, C-A-F. He is a major arc. And we have a formula. So if we want to find, so remember circumference was when we went all the way around the circle, we measured it. We could also measure this, but we need to know some angle measures. But it's going to be the exact same idea as over here, okay? So you're going to take your circumference formula, so like pi times diameter, so pi times diameter, and you're going to multiply that by the measure of however big your arc is over 360. So that you're going to do that times the measure of the angle over 360. So it's the same idea both times. So if you're going to do the area of the whole circle, you do your formula. If you want part of the circle area, you're going to multiply by the measure of the angle over 360. Same thing here. If you want the length all the way around a circle, you just use diameter. If I want the length just some of the way around, I have to do the whole thing times the measure over 360. So it's basically the fractional part of the circle that you want. And we are going to do those last 2 examples and then we have everyone here tomorrow. Okay? But we are gluing this onto page 60. Okay? Gluing onto page 60.